Welcome to another video. We have been solving a bunch of textbook problems to practice our techniques of integration. So I've been solving the problems from the James Stewart Calculus Early Transcendental textbook, the 7th edition, section 7.5. And we left off on number 50, so let's begin. Integral 1 over x squared, square root of 4x plus 1, dx. How do we solve this? This is actually very similar to the last problem, number 49, except now it's x squared instead of x, if you've seen the last episode. Okay, so here, let's go down, list as usual. Can we do like an integration by parts? Well, it is a product of two things, for example, 1 over x squared and 1 over square root of 4x plus 1, but it seems complicated if we do integration by parts. So let's maybe avoid that. Maybe we have to do it, but let's kind of leave that as one of the last resorts. It's not a trig integral, clearly. It's not a trig sub because if it were under the square root, it was something squared, at least a quadratic, then we could maybe complete the square and force it to be a nice perfect square. And then maybe we can do trig sub, but we don't even have a quadratic underneath the square root, so probably not trig sub. Not partial fraction decomposition because it's not a rational function, really. Not one of the nice ones that we can factor in all that because of the square root. So what about substitution? So if we've seen the number 49, we made a substitution in that problem. U is the square root 4x plus 1. Maybe let's do that over here to try to kind of get rid of it. So U square root of 4x plus 1. Okay. Remember, we can square both sides to make the differentiation a little nicer. So it'll be u squared is 4x plus 1. So 2u du would be 4 dx. Or we can simplify, u du would be 2 dx. Or we can just say half u du is dx. Okay? So we also need to get x squared in our substitution. So how can we get x squared? Let's use this definition of u. So u squared, or even here, u squared minus 1 over 4 is equal to x. Okay, so to get x squared, we just square both sides. Okay, so x squared we can even write as 1 over 16, u squared minus 1 squared. Okay, now let's substitute. This is integral of dx is on top. Dx is half u du. X squared we found over here. 1 over 16 u squared minus 1 squared times the square root term is just u. Okay, so now let's simplify a little bit. This u and this u would cancel. This is just a 16 on top. 16 divided by 2 is 8. So we can pull the 8 out as a constant. So we have du over here, we can even factor. It'll be u plus 1, u minus 1. That's u squared minus 1. And then this whole thing is squared. Why do I want to do that? Well, hopefully you can see that we can do partial fraction decomposition. It'll be u plus 1 squared, u minus 1 squared. Okay, so now how do we solve this guy? As I just said, partial fraction decomposition. Here we have repeated terms, so we got to be careful. Okay, so let me just do it over here then. Okay, so we'll ignore the 8 for now. When we do partial fraction decomposition, remember, when we have repeated linear terms, we have to go like this. A over u plus 1 plus b over u plus 1 squared plus c over u minus 1 plus d over u minus 1 squared. So this is equal to 1 over u plus 1 squared, u minus 1 squared. Okay, or we can even put the 8 back in. Maybe that'll be nicer actually. So let's do that. Okay, so how do we approach partial fraction decomposition? We multiply both sides by this denominator. So we get a u plus 1 u minus 1 squared plus b u minus 1 squared plus c u minus 1 u plus 1 squared plus d u plus 1 squared, which is equal to 8. Okay, So now let's plug in two easy numbers, like u is -1. Why do we want to do that? Well, this would go away. This wouldn't go away. We get -1 minus 1, which is -2. Square that, which is 4. So 4b, u as -1, this would go away, this would go away. 4b is equal to 8, so b is equal to 2. Okay, so we can plug in u is 1 also. This would go away, this would go away, this would go away. We get 4d is equal to 8. So d is also equal to 2. Okay, so we still have a and c to find. We can plug in two other numbers, like u is 0, for example. We would get a, let me just write the whole thing out, a times 1 minus 1 squared plus b minus 1 squared plus c times minus 1, 1 squared plus d, 1 squared, which is equal to 8. Okay, so we simplify. We get a plus b minus c plus d is equal to 8. So we have third equation. We plug in another number, like u is, for example, we can plug in u is 2. Okay, so we get a times 3 times 1 squared plus b times 1 squared plus c times 1 times 3 squared plus d times 3 squared is equal to 8. Okay, so we're getting a little closer. So we get 3a plus b plus 9c plus 9d is equal to 8. Okay, so now we got to solve the system of equations. 4 equations, 4 knowns, so we can do it. Okay, so let's plug in b and d as 2 into these two equations. So let me even use a different color. So a plus d would be 8 minus, or sorry, I don't want a plus d. I want a minus c is equal to 8 minus b minus d. Okay, we said b and d were 2, so it'll be 8 minus 2 minus 2, which is 4. So we get a minus c is equal to 4. Okay, similarly over here, we get 3a plus 9c is equal to 8 minus b minus 9d, okay, which is equal to 8 minus 2 minus 18, which is equal to what? It would be minus 12. Okay, so we can say 3a plus 9c is minus 12. Let's solve the systems of equations. We can actually reduce this even to a plus 3c is equal to minus 4 divided by, multiplied by 1/4 on both sides. Sorry, 1/3. Or divide by 3 on both sides. Okay, so now this makes it easier. So let me do that over here now. A minus c is equal to 4. And we have a plus 3c is minus 4. Okay, so we can subtract these two rows. What do we get? We get minus 4c is equal to, because it's minus c minus 3c, so that's minus 4c. This is 4 plus 4, which is 8, so c is -2. Okay, and then we can get a, because we can just use this definition, a minus -2 is equal to 4. Okay, so a is equal to, that is a plus 2, so it'll be a is 4 minus 2, which is 2. Okay, so we can finally write our integral I as our partial fraction. So I don't know, okay, there we go, you kind of see it on camera, the whole thing. Okay, so actually, you cannot. Okay, so we're going to basically plug in our A, B, C, D that we found into here. Okay, so we would get integral A was 2, so 2 over u plus 1 B was, what was B? B was also 2. So plus 2 over u plus 1 squared. C was minus 2, so minus 2 over u minus 1. D was positive 2, so plus 2 over u minus 1 squared. This whole thing by du. Okay, so this is just 2 log u plus 1. This is power rule over here, so it would be minus 2 over u plus 1. Let me check by differentiating. This is u plus 1 to negative 1 power, so it'll be bring the minus 1 down, so it becomes a plus 2, u plus 1 to the minus 2 power, which is that times derivative inside, which is just 1. Okay, that's good. So minus 2 log of u minus 1. So this is again minus 2 over u minus 1. Okay, plus c. And then we back substitute. What was our u? We have to go all the way up here. U is square root of 4x plus 1. So it'll be 2 log square root of 4x plus 1 minus 2 over square root of 4x plus 1 plus 1 minus 2 log the square root of 4x plus 1 minus 1. I think I've got plus 1 over here. My bad. And then minus 2 over square root of 4x plus 1 minus 1 plus c. And that's my answer. Hopefully I did this right. It looks, I checked on Wolfram Alpha, and it looks similar. It's because Wolfram Alpha put it as hyperbolic tangents, but I don't quite remember what that is off the top of my head. But in their other alternate forms, it looks very close to this, actually. They rationalized it and all that. So you can just double check for me if this is right, but this is the technique that I went about. All right, so maybe we can only do 2 problems in this video. So let's see how 51 looks. Okay, 51 is very similar to what we just did. It's different again. So instead of x, it's a x squared outside, it's an x here. Okay, and then instead of 4x, it's 4x squared inside the square root. Okay, so again, looks similar to 49 and 50, but with the square here, it actually makes our life a little easier. Okay, and in fact, you can do a trig sub here because it's something squared plus something squared. Hopefully you can see that if we set up a triangle, you don't even have to put the square or do a little substitution or anything like that. You could, if you want to, make a substitution of u is 2x. That'll be totally fine. But actually, you can directly substitute from here. Because we know that if we consider the Pythagorean theorem, it'll be something squared plus something squared is the hypotenuse. So this side is the hypotenuse. Okay, so 1 would be one of the sides. And then 2x would be the other side, actually. Because it'll be 2x squared, which is 4x squared, plus 1 squared is equal to this square. So the Pythagorean theorem works. All right? So we can actually set up a triangle like this. So let's do a trig sub. We want everything here in terms of theta. So how do we do that? We need x. So to get x, we see that, let me go a little slower here because this is 2x here. So it'll be tangent theta is 2x over 1. So x would be half tangent theta. Okay, so dx would be half secant squared theta d theta. And as always, we can sub in the square root term also. Square root of 4x squared plus 1. What is that? Secant theta is square root term over 1. So it's just secant theta. All right? So this is actually quite simple trig sub. We'll see if you trigonometrical that results is easy though. So we have a dx on top, so half secant squared theta, d theta is on top. At the bottom we have an x, which we said was half tangent theta, and the square root term, which we said was secant theta. Okay, so we see that the halves would cancel. We can reduce 1 power of the secant on top because there's a secant on the bottom. So we get integral secant theta over tangent theta d theta. How do we solve this? I would just change this in terms of sine and cosine. So secant is 1 over cosine theta. Tangent is at the bottom, so it's cotangent at the top then, technically. Or you can think of it as tangent sine of cosine. We're just going to invert it. So it's cosine theta over sine theta, which I said was cotangent, right? So this is our integral. We see the cosines cancel. So we have the integral of cosecant theta d theta. And this is in the table. This is log of cosecant theta minus cotangent theta plus c. Okay, now we back substitute. We need cosecant theta and cotangent theta. Okay, so cosecant would be square root over 2x. Okay, cotangent would be 1 over 2x. And this is my answer. So this one was pretty quick, actually. We just had to do a trig sub. Okay, again, double check my answer is correct, but this one, hopefully the technique was clear. All right. Yeah, it's 16 minutes into this video, so let me call it a part here. Please like this video as always if you found it helpful at all. You know, it was just 2 problems. Hopefully, especially this one, just going through the motions was helpful for you. Okay, and please subscribe also if you haven't already. And finally, please look out for the next video where I'll solve a few more problems. Hopefully I see you in that video. Bye.